Okay, I'm going to talk about equations with fractions. Now I'm going to take some examples off here. I'm also going to take some examples from elsewhere, okay, which are not on here. So there's some of these are going to be on there, and then there's going to be others that are not on there at all. Okay. Equations with fractions. Okay. No variables in denominator. So I'm going to go ahead and put agenda up here. No variables in the denominator. Okay, the other one is one variable in denominator. And then the next one, multi-variable equations. Okay, I'll put a check mark by each agenda item when I'm finished with it. Okay, or I'll put done next to it I'll put done next to it, or I'll put a check mark, or I'll do both. I'll decide when I get there. So the first part is example 1. We have 5x over 6 minus 2 equals x plus 13 over 4. Now, the LCD, least common denominator between 4 and 6. 2 is in the denominator, 6 and 4 are the denominators. Lowest number that 6 and 4 divide evenly is 12. Okay? Next, we multiply everything by 12. If a fraction has more than one term in the numerator, you're going to want to put it in parentheses. This helps avoid distributive property mistakes. So 12, and then you cancel away the denominators by dividing. 12 divided by 6 leaves you 2. 12 divided by 4 leaves you 3. So we have 2 times 5x minus, well, I'm going to do that multiplication. And then this is going to be 3 times x plus 13. Distributive property. And we have 10x minus 24 equals 3x plus 39. We got x's on both sides, so we will subtract. And 7x minus 24 equals 39. Add your 24 back. And 7x equals 63. Divide by 7, divide by 7. X is 9 when you divide. Okay? With example 2, okay, I'm going to put that on the board, but I will also erase it. Okay? Example 2, x plus 5, or x over 5 plus 3 equals 4/5. So the LCD is just 5. So we will now proceed to multiply everything by 5. So 5 times x over 5 plus 5 times 3 equals 5 times 4/5. Okay? 5 divided by 5 is 1. 5 divided by 5 is 4. Or 5 divided by 5 is 1. And 1 times 4 is 4. 1 times x is x, and I'm going to keep the 15. Okay? Subtract the 15. And x equals negative 11. So that's how that works. I'm going to keep this one. I'm going to erase this one. Okay? So we are done with this one. Okay, we're done with the first agenda item. Okay. Variable in denominator. Okay, so here we are with a variable in the denominator. Dropped it. Okay, so we're here, and we are at 2x over x minus 2 plus 3 equals 14 over x minus 2. Now, unlike the other problem, we have to find the excluded value, or values in some cases. X minus 2 cannot equal 0. No denominator can equal 0 because division by 0 doesn't exist. So we have to avoid situations where the denominator could equal 0. So add your 2, and x cannot equal 2. So if we do a whole bunch of algebra and it turns out that the only solution available is 2, then we don't have a solution. All right, so here goes. We're going to multiply, and oh, by the way, the LCD is the only denominator that we see, which is x minus 2. So we will now multiply everything by x minus 2. Okay? Cancel, 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 cancel. There should be no more denominators. That's the point of multiplying by the LCD. So there should be no denominators when you're done. So we'll just have 2x plus 3, x minus 2 equals 14 when it's all cleaned up. Distribute. And we end up with 2x plus 3x minus 6 equals 14, and these two combine into 5x minus 6 equals 14. Add your 6, you get 5x equals 20. Okay? Divide off the 5, divide off the 5, divide by 5, x equals 4. You check to see if it's on the excluded value list. It isn't. Okay? So it's not excluded. Not excluded. It's not excluded. So x equals 4. Okay? So it's similar to the other problem, the one where the variables are not in the denominator. The only difference is you have to find an excluded value first, okay, or at some point. So I'm going to erase, so this was example 1 of variables in the denominator. I'm going to erase this and put example 2 up here. Example 2 is 5x over x plus 3 minus 4 equals negative 15 over x plus 3. Excluded value, x plus 3 cannot equal 0. So x cannot equal negative 3. Okay, x plus 3 does not equal 0. Subtract x does not equal negative 3. And the LCD, least common denominator, is x plus 3. So we will now proceed to multiply everything by x plus 3. Okay? So, cancel, cancel. The whole point of this is to get rid of our denominators. Okay, so we're left with 5x minus 4x minus 12 equals negative 15. That combines into just a single x. Add your 12, and we get the idea that x is equal to negative 3. But it's on the excluded value list. So it's out. So there is no solution. Okay? Example 3 is more of the same. So I'm going to go ahead and go on to example 4 on here. Okay? And then after this, the examples are going to be off script. Okay, so example 4. 5 over x plus 3 plus 1 over x minus 2 equals 8 over x squared plus x minus 6. First thing you're going to want to do is factor this. So x plus 3, x minus 2. All right, now because this includes, this includes the other denominator as factors, it's the LCD. Okay? Because it's got all the other denominators included as factors. So the LCD is taken care of, and the excluded values, there are 2 of them. X plus 3 cannot equal 0. X minus 2 cannot equal 0. So subtract 3, x cannot equal negative 3. Add your 2, x cannot equal 2. Okay, we will now proceed to multiply everything by the LCD. So, times x plus 3, x minus 2, plus 1 over. I'm going to need to move it over. Sorry, there won't be enough room. So 5 over x plus 3 times x plus 3, x minus 2, plus 1 over x minus 2 times x plus 3, x minus 2, equals 8 over x plus 3, x minus 2, times x plus 3, x minus 2. Oh, great, it all fits. Okay, good. All right, so the whole point of this is to cancel away the denominators. So we do exactly that. This cancels against this cancels against this, and both of these cancel against their counterparts. Okay? So that leaves me 5 times x minus 2 plus 1 times x plus 3 equals 8. So that gives me 5x minus 10 plus x plus 3 equals 8. These two combine to 6x. These two combine to minus 7, and that equals 8. Add your 7. 6x equals 15. We need to divide off the 6. Sixes cancel, and this reduces to x equals 5 halves. It's not excluded. Not excluded. So x equals 5 halves is the solution. Okay. So the next bunch of problems I have, there are no handouts for. At least not, they aren't attached to this one. So this part, done. And finally, we're going to do multivariable equations. All right, so here goes. So multivariable equations. Okay? Example 1, which is not in the document that's attached to this video, is solve capital F equals 2y over x minus c for x. We don't worry about the excluded value, but the LCD is x minus c. So we will multiply everything by x minus c. Okay? By the way, variables are case sensitive. If the formula or equation has capital F and you use lowercase f, you're going to be counted wrong most of the time. Okay? So cancel, cancel. So f times x minus f times c is 2y, because that's a distributive property situation. Okay? We now want to isolate the x. So I want the x term by itself, so we will add fc. These are unlike terms, so they need to be kept separate. F times x equals 2y plus capital F times c. We then do this multiplication by dividing. Those cancel, and x equals 2y plus capital FC over f. Okay? Here's another one. Capital A equals lowercase a plus c over c minus 4 for c. Both of these are supposed to be lowercase. Now these two A's, they're different. They represent two different values. Okay? So the first thing we do is we worry about the LCD. So we'll multiply A and C minus 4 equals lowercase a plus lowercase c times lowercase c minus 4 times c minus 4. Cancel, cancel. If the c is in parentheses, we use the distributive property to get it out. Okay? Get c out of parentheses. Okay? So, distribute. AC minus 4 capital A equals A plus C. Get C to one side and isolate. So that's your next step. Anytime you got two appearances of the variable you're interested in, you need to get them both to one side. And then you want to isolate them. So we will subtract the C to get to one side. We want to minimize our signs. So this is AC plus negative C. Instead of treating it as an addition of a negative, we'll treat it as subtraction. So AC minus C minus 4A equals lowercase a. Remember, we still want to isolate. So we want to get the C terms by their lonesome, so we will add the 4 uppercase A. Okay? So we have A times C minus lowercase c equals lowercase a plus 4 capital A. If you have two factors, if you have two or more appearances of your target variable, like you do here, factor it out. Factor out C. So C, AC divided by C is A. Negative C divided by C is minus 1. Okay. I factored it out. The last thing we're going to do is divide off the other factor. Divide. So we have C times A capital A minus 1 equals A plus 4A. We will divide by capital A minus 1, capital A minus 1, cancel, cancel. So lowercase c equals lowercase a plus 4 capital A over capital A minus 1. And we're done. Okay? Let me get this one off the board. I'm going to try and fit in a similar problem here. Okay? Z equals 5x plus 9 over x minus 4 for x. Make it 14. So the LCD equals x minus 14. So we're going to take z times x minus 14 equals 5x plus 9 over x minus 14 times x minus 14. Cancel, cancel, and we want to do the same things that we did earlier. Get x out of the parentheses. So distribute zx minus 14z equals 5x plus 9. Get x to one side. Like we did earlier. So we'd have zx minus 5x minus 14z plot equals equals 9. And then we want to isolate x. So we would add the 14z plus 14z. So zx minus 5x equals 9 plus 14z. Okay. Factor out x. Okay, so x, the factoring out that x will leave me z minus 5. And then we're going to divide. Okay. So we end up with x times z minus 5 cancels against the z minus 5 equals 9 plus 14z over z minus 5. These cancel, and the only thing I'm left with is x equals this over this, 9 plus 14z over z minus 5. Okay. There's one more problem that I'd like to do, but these are similar and you're going to have a lot of these. Again, this is not in your paper, attached document. Example 4. We have 3 over a plus 5 over b equals, now let me make it 6b. 6b over 2/7 for b. Okay, so the LCD, among the numbers, lowest number at 7, 6 divided evenly is 42, and we keep both variables. So we will now multiply everything times the LCD. So 3 over a times 42ab plus 5 over 6b times 42ab equals 2/7 times 42ab. All right. Cancel your eggs. Okay? In this situation. Cancel, so 42 divided by 6 is 7. Your b's also cancel. The a will be unaffected. And 42 divided by 7 is 6. So we have 3 times 42 is 126b plus 35 times a equals 12ab. What we want to do is get b to one side, because that's what we're solving for. So I got a b term on this side. Normally we bring them Normally we try to put them on the left. We're going to treat the subtraction of this the addition of this the addition of this negative as a subtraction. So 126b minus 12ab plus 35a equals 0. Isolate b. Okay, so we subtract the 35a. Okay, so that leaves me 126b minus 12ab equals negative 35a, because 0 minus 35a is negative 35a. Same as what we did here. We got two appearances of b, so we factor out b. We factor out b. If we got two terms of it, we factor it out. So b, and then we get 126 minus 12a equals negative 35a. And then like we did over there, we divide. Okay, so that leaves me divide cancel, cancel. That's the whole point. We canceled these. So we're just left with b equals negative 35a over 126 minus 12 lowercase a. Okay? That's it. Okay? That's where I'm going to stop.